Hello there and welcome to Solving Trig Equations, the type of equations that involve angle addition formulae. Okay, so we're going to go through a whole bunch of questions here relating to solving trigonometric equations. These are pretty hard equations. Each equation will take me a little bit of time to do and we'll work through them steady and methodically through each one. So pause the video whenever you get to a question, give it a good go yourself and then play the video to see if you've got the answer correct. And if you've not got the answer correct, or if you're stuck on a question, then play the first little bit of the video, see what I do to start with, and then at any point in that introduction to the question, in the first part of the question, pause the video if you've then had a brainwave as to how to answer this question, and then carry on the question for yourself. Always be trying to do things as much as possible for yourself. That's how you're going to learn most optimally. So we'll get started on these questions then. So pause the video, give this one a go here. Okay, so in this question here we've got cos 2x and cos of x. So I'm going to want to use a double angle formula for cos 2x to turn it into something related to cos. Now, one of the double angle formulas that I've remembered off by heart, and you should remember a few off by heart because it's really helpful to just have them instantly recallable at your fingertips, is 2 cos squared minus 1. So I know that that is an identity and I'm now going to use it in this question. So 2 cos squared x minus 1 plus cos equals 0. Let's just rearrange that so it looks a bit more like a quadratic. So I'll put the cos first and then the minus 1 next. Next thing I'll do is I'll do a bit of factorising, so it'd be 2 cos x and cos x. And then I need to think what will go at the ends of these brackets. I think it would be plus 1 here and minus 1 up here. So therefore we've got two trig equations, two smaller ones for the price of one. Either cos of x will equal a half to make that bracket equal 0, or cos of x equals minus 1. And in this case here it's going to be at 60 degrees and 300 degrees. And for this one over here, x is going to equal 180 degrees. So there we are, those are the three answers for this question. Okay, let's move on to the next one. So we're going to be using sine 2x identity here, and the sine 2x identity is 2 sine x cos x. So let's now use that in the question. So it's going to now be 2 sine x cos x plus cos x equals 0. Now what you definitely don't want to do at this point is divide by cos, because you'll be losing some of your solutions. You factorise out cos at this point. So cos of x will go at the front of the bracket, and then 2 sine x plus 1 will go inside the brackets. And now you've got two expressions that are multiplying together to make 0. So either the first one is equal to 0, cos x equals 0, or sine x is equal to minus a half. So in the first one, it will be at pi by 2 and 3 pi by 2. And in this one here, it's going to be, well, it would be pi by 6 normally. So it's going to be 4 pi by 6. So that will be added on to, so let's just work this out. So it's going to be, the sine graph looks like this one here. So minus a half will be down here. So I'm going to get some solutions here and here. A half would have a solution at pi by 6. So it's going to be from pi on that axis there onwards by pi by 6. That little gap there is a pi by 6 gap. So the answer is going to be 7 pi by 6. And from the other direction at 2 pi, it's going to come backwards by pi by 6. So that's going to make it 11 pi by 6. So there we are. Those are the four answers for this question. Let's move on to the next question. And it's this one here. And we've got a cos 2x in terms of, and we want to turn it into something in terms of sine. So one of the cos double angle formulas that I remember is 1 minus 2 sine squared x. So I'm now going to use that in this question. So I'm going to write 2 brackets 1 minus 2 sine squared x equals 7 sine x. Next thing I'll do is I'll expand the brackets. 2 minus 4 sine squared x equals 7 sine x. Next thing I'll do is I'll move everything to the right hand side. So 4 sine squared x plus 7 sine x minus 2. On the right hand side, let's factorize it. I think it will be a 4 sine in the bracket. And then sine in this one. So I'm pretty sure it's going to be a plus 2 over here and a minus 1 over here. When we factorize that out and we expand the brackets on that, we're going to get 7 sine x. So what do we get in terms of sine? Sine x is either equal to 1/4 or sine x equals minus 2. And in the real numbers, that's definitely not going to happen. So no solutions there. Next thing I need to do is grab my calculator and make sure it's in degrees mode, because if the question is from 0 to 360, it's definitely going to be a question in degrees mode. So my calculator's in degrees mode. I'm going to do sine inverse 0.25 and I get 14.5. And the next answer will be 180 minus this, and that's going to be 166. So there we are. Those are the two answers when rounded to 3 significant figures. Okay, let's move on to the next question. And in this question, I've got a cos 2x, and I'd like to turn it into something related to cos. So I'm going to remember that identity of cos 2x is identical to 2 cos squared x minus 1. So I'm going to use that in this position here in this equation. So it's going to be 11 cos x equals 4 plus 3 brackets 2 cos squared x minus 1. I'll now open up the bracket on the right hand side. It's going to be 4 plus 6 cos squared x minus 3. So when I move everything onto the left hand side, I'm going to get 6 cos squared x minus 11 cos x and then plus 1. Okay, so the next thing I'm going to do is I'm going to factorize it, and it could be a 6 cos x and a cos x, or it could be a 3 cos x. 4 cos. It could be a 6 and a 1, 6 and 2. No, I'm not sure what this is going to be. No, so I'm not sure that this is factorizable, so I'll have to go to the quadratic polynomial solver, and either cos x will equal 1.74, no, there's going to be no solutions there, or the second solution is 0.0959. 0.0959. So the next thing to do will be to solve the equation for this solution here. So it's going to be in degrees mode, cos inverse of that answer. So cos inverse answer, and that's going to give us 84.5. And then the next solution is going to be 360 minus that, and that's going to be 276. So there we are, those are the two answers for this question. Let's move on to the next one then, and it's tan 2x minus tan x equals 0. So the tan 2x identity, helpful one to remember, is 2 tan x over 1 minus tan squared. Okay, so I'll use that in this question here then, so it's going to be 2 tan x over 1 minus tan squared x minus tan x equals 0. Now the first thing I'll do here is I'll factorise out the tan. So tan x bracket 2 over 1 minus tan squared x minus 1 will equal 0. So either I've got tan x equals 0, in which case I get solutions of 0, pi and 2 pi, or we'll carry on with this expression here. So therefore 2 will equal 1 minus tan squared x, in which case tan squared x will equal minus 1, which has no solutions, because you can't square something to get minus 1. So there we are, that's the answer to this question then. So the answers are just 0, pi and 2 pi. Okay, so let's move on to the next question then, and I can't see any double angle formulas yet, so we'll do a bit of rearranging and see if we can come across a double angle formula. Now sec I know to be 1 over cos, so that's the first thing I'll write down. This is 1 over cos, and that'll be minus 4 sine x equals 0. And I think the second thing I'll do is move the negative 4 sine x onto the other side. So it'd be equals 4 sine x. And then to undo this 1 over cos, I'll multiply both sides by cos. Okay, now what I've got on the right hand side looks very familiar to the identity of sine 2x equals 2 sine x cos x. But on the right hand side I've got a 4 there instead. So if I just multiply both sides by 2 on this thing here, then I've got 2 sine 2x is equal to what I've got exactly on the right hand side. So it's going to be 2 sine 2x. The next thing I'll do is I'll divide by that 2 at the front. And now I've got a little equation to solve. So how do I solve these types of equations? Well, I need to first double the angle that I'm working with, because it's a sine 2x on the angle there. And then inverse the sign. So 2x is going to equal, between 0 to 4 pi, it's going to be pi by 6, 5 pi by 6, then add on 2 pi to that, so that would be 13 pi by 6, and 17 pi by 6. And the last thing I'll do is I'll divide all of these solutions by 2, so my answer here is pi by 12, 5 pi by 12, 13 pi by 12, and 17 pi by 12. So there we are. So it wasn't a double angle formula, it wasn't a double angle in the question, but I changed it by manipulating it into a point where I could use a double angle formula to help me out in the question. Okay, let's move on to the next question. So let's have a go at this one. So what I can see in this one is I've got a cos 2x. So cos 2x has the identity of 2 cos squared x minus 1. So let's substitute that into the formula. So it's going to be 2 cos squared x. I'm going to save this minus 1 to group it up with the minus 1 at the back. Plus 3 cos x. And then minus 2 equals 0. Because I've got this minus 1 and that minus 1. And they'll team up to make minus 2. The next thing I'll do is I'll do a bit of factorising. 2 cos x bracket cos x. And in this one I think I'll need a plus 2 on this side and a minus 1 on this side. That'll make 4 cos x minus cos x. That'll give me 3 cos x. So either I've got cos x equals minus 2, in which case there's no real solutions, or cos x equals half. And in degrees mode, that's going to be x equals 60 degrees and 300 degrees. So there we are, those are the two answers for this question. Let's move on to the next one. Quite a difficult question, this one. 5 sine 4x equals 2 sine 2x. I think what I'll do is I'll use the double angle formula on the left-hand side. Now, reminder, the double angle formula for sine is sine 2 theta equals 2 sine theta cos theta. But if I now replace from this line to the next line theta with 2x, then it's going to be sine of, well, 2 times 2x is 4x, which is equal to 2 sine theta is 2x, remember, so sine 2x cos 2x. Okay, so that's what the angle identity is for sine 4x. It's 2 sine 2x cos 2x. So let's use that. It's going to be 5 multiplied by the 2, so let's make it 10 to get the ball rolling. 10 sine 2x cos 2x equals 2 sine 2x. Now, what you definitely shouldn't do in this situation here is divide by sine 2x on both sides, because you'll be losing some solutions that way. What you should do is subtract sine 2x from 2 sine 2x from both sides. So sine 2x cos 2x minus 2 sine 2x. And now let's factorise it out. And in fact, we could even factorise a 2 out to the front as well. So it would be 5 cos 2x minus 1 equals 0. So now we've got two equations, either sine 2x equals 0, or we have cos 2x equals 1/5. Now the first thing I need to do, so I'm not going to expand these as double angle formulas. What I'm going to do instead at this stage is I'm going to multiply my angles. So my angle here is now going to be looking for solutions in between 0 to 2x to 720 degrees. So for this little baby one on the left hand side here, sine 2x, I'm going to have solutions of 0, 180, 360, 540 and 720. I'm going to save the working out x for last, and I'm going to do the cos 2x equals 1/5 now. So in this case it's going to be cos inverse of 1/5, and we're in degrees mode, so just check your calculators on that mode before you do anything else. So I'm going to have 2x is equal to 78.5 degrees. Now what I'm going to do next, I'm going to store it as the value a in the calculator. So it's now a. And then the next thing I'm going to do, because it's a cos angle, is I'm going to do 360 minus that value a, and that will give me 282. Now at some point I'm going to need to divide all these angles by 2, so I'll start doing it now. So that 282 will need to be divided by 2 to give me 141. The next solution on for 2x is going to be 360 add that angle A, so that would be 438, and then at some point I'm going to have to half it, so while it's in my calculator I'll divide it by 2 and I'll get 219. And the last solution there will be 720 minus the angle A, so that's 642. And at some point I'm going to have to half it, so divide it by 2 now, and I'm going to get 321. Going back to the first solution there, A divided by 2 was 39.2. And dividing all of these angles by 2, I'm going to get 0, 90, 180, 270, and 360. So there we are, we have quite a few solutions here. 5 over this side and 4 over this side, and it might just be worth checking one of your answers. So type in 5 times sine of 4 times 321, and you get approximately -2, and then do the same on the other side. 2 times sine of 2 times 321, and you get about -2 as well. So yeah, that's all good. We get the same answers on both sides. Okay, let's move on to the next question then, and we've got a 2 sine squared minus cos 2x minus cos equals 0. Now what I do remember is there is some link between these two expressions here. I do remember that cos 2x is equal to 1 minus 2 sine squared x. So if I now rearrange this identity a little bit, and then the next thing I'll do is I'll put cos 2x into that slot there. So it's going to be 2 sine squared x minus, in brackets, 1 minus 2 sine squared x minus cos x equals 0. I'm not too worried about the cos x on the right hand side at the moment, because I can always turn sine squared into cos squared by that famous identity, sine squared plus cos squared equals 1. So when I expand the brackets, I'm actually going to get 4 sine squared minus 1 minus cos x equals 0. I'm now going to replace the sine squared with 1 minus cos squared, and it'd be minus 1 minus cos x equals 0. So expanding the brackets now, I'm going to get 4 minus 4 cos squared x minus 1 minus cos x equals 0. And the next thing I'll do is I'll move everything onto the other side. So I'll add the 4 cos squared onto the right, I'm going to add the cos x onto the right, and then the 4 and the minus 1 will make 3, but then I need to take it away on the other side, so it'll be minus 3. So the next thing I'm going to need to do then is solve this little quadratic. And I think this one factorizes. It's going to be 4 cos x on one side, and then it's going to be cos x on the other side. I'm going to probably put the minus 3 on this side and the plus 1 on that side, because then when I expand I get 4 cos x and then minus 3 cos x, that'd be cos x, lovely. So here I get cos x equals 3/4 and cos x equals minus 1. Now x will equal pi when that happens with this one, but the first one was slightly more complicated, so I'll need to put my calculator into radians mode now. And the next thing I'll do is then do cos inverse of 3/4, and that will give me x equals 0.723 to 3 significant figures, and then the next solution for cos will be 2 pi minus answer, and that will give me 5.56 as my second answer on that equation. So it's going to be pi and these two answers up here. Lovely, there we are. Let's move on to the next question, and we've got this one here. We've seen a very similar one to this one beforehand. Let's give this one a go. I've got the identity of sine 2x being 2 sine x cos x, and this time I'm pretty confident I'm going to put it straight in. Equals 3 cos x. I'll expand the brackets then, so it's going to be 4 sine x cos x equals 3 cos x. Now, hopefully you've learnt by now, definitely do not divide by cos at this point, otherwise you'll lose some solutions. The next thing you should do is subtract the 3 cos x onto the left-hand side. And then factorize out the cos, so it's now 4 sine x minus 3 equals 0. So then we've got two equations for the price of one, either cos x equals 0, and in which case that's going to be pi by 2 and 3 pi by 2. And on the other side, sine x is going to equal 3/4. So we need to put our calculator in radians mode and then do sine inverse 0.75 or 3/4, and that's going to give us 0.848. And then with the sine equation we need to do then pi minus answer, and that's going to give us 2.29. So we've got these two solutions here and these two solutions here in between 0 to 2 pi. So there we are, that's the answer for these two questions, this question here. Let's move on to the next one, and in this question we want to turn 3 cos 2x into something related to sine. So I remember that there's an identity for cos 2x that goes 1 minus 2 sine squared x, and then it would be the rest of the equation, minus 8 sine x plus 5 equals 0. Let's expand the brackets. We're going to get 3 minus 6 sine squared x minus 8 sine x plus 5 equals 0. Let's now move everything onto the right hand side. So the 6 sine squared x will move onto that side. The minus 8 sine x will become plus 8 sine x when it's on the right hand side, and we're going to get 3 and 5 adding together to make 8, so it's going to be minus 8 when it's on the other side. The next thing I'll do is I'll divide everything by 2, because that'll make my life easier. I'm all about making my life easier. The next thing I'll do is now factorize or solve this quadratic. And let's see if I can factorize this. It's going to be 3 sine x and sine x on this side, and it's probably going to be a 2, so if I put a plus 2 on this side and a minus 2 on that side, that's going to make it 6 sine x and minus 2 sine x, that'll make it 4 sine x, lovely. So I get two equations here, sine x equals 2/3, or sine x equals minus 2. There's no chance of that happening in the real numbers between 0 to 2 pi, so we've just got the left hand one to solve. So I'm then going to do sine inverse, making sure my calculator's in radians mode, sine inverse of 2/3, which is 0.730, so 3 significant figures, and then for sine, the next solution is going to be pi minus answer, which is 2.41. So there we are, those are the two solutions for this equation. Let's move on to the next one. So once again, I'm looking to turn cos 2x into something related to sine. So in this question, it's going to be 1 minus 2 sine squared x plus 3 sine x equals 4. Expand the brackets, I get 5 minus 10 sine squared x plus 3 sine x equals 4. Move everything onto the right hand side and you get 10 sine squared x minus 3 sine x, and then it's going to be minus 1 on the right hand side because I have to take away the 5 from the 4. Let's now see what I can do with factorising this. And I'm going to get, maybe we'll factorise it into a 5 and a 2, so 5 sine x and a 2 sine x. And I think if I put the minus 1 on this side and the plus 1 on this side, then that's going to make it 5 sine x minus 2 sine x. So minus 5 sine x plus 2 sine x, I mean minus 3 sine x, lovely. So my two solutions here are going to be sine x equals minus a fifth, and sine x equals a half. And in between 0 to 360, the second equation will be 30 and 150. And then this side will be slightly more difficult because I'll have to use my calculator. Sine inverse, I'm in radians mode at the moment, I'll need to change it to degrees mode. So into degrees mode, and it's going to be sine inverse minus 0.2, that's minus a fifth, and that will give me minus 11.54. So what does that mean on the sine graph? What it's probably done is it's probably given me this solution down here at minus 11.54, so I have to take that minus 11.54 and add it onto 180 and then take it off of 360. So my next solutions are going to be 180 plus that 11.54. I'll make sure I do it on my calculator properly and do 180 minus answer. And that will give me 192 when rounded to 3 significant figures. And the next one is going to be 360 plus answer, which will be 348. So it'll be 360 minus 11.54. That'll be 348 when rounded to 3 significant figures. So it's that answer, and then these two up here. So there we are, that's the answer to this question. Okay, let's move on to the next question, and in this question we've got cos 2x and we want to turn it into something related to cos. So remember that there's the identity cos squared x minus 1, that's equivalent to cos 2x, and then it would be minus cos x plus 1 equals 0. So let's expand those brackets. 6 cos squared x minus 3 minus cos x plus 1 equals 0. So let's just simplify what we've got here, turn it into a quadratic, and it's going to be 6 cos squared minus cos x minus 2 equals 0. And then we need to think about how we'll factorize this. I reckon if we put it as 3 cos x and 2 cos x, that might help us. How are we going to do this? It's probably going to be the minus 2 here and the plus 1 here, because that'll make minus 4, and plus 3, that'll make it minus cos x. So in this question I'm getting cos x equals 2/3 and cos x equals minus a half. So therefore x is equal to, let's grab the calculator, it's in degrees mode now, so cos inverse 2 divided by 3, which is 48.2. And then the next solution for cos is 360 minus answer, which is 312. For this solution, for this equation over here, it's going to be cos inverse minus 0.5, which is 120, and the same again, 360 minus 120 is 240. So there we are, 4 answers for this question. There we are. Okay, let's move on to the next question. Wow, okay, this is a difficult question. So we've got 2 sine 2x. So we've got sine 2x. Now the only thing you can really do with this is turn it into its double angle identity. There's only one of these, so we don't necessarily need to choose. But that's what it's equal to. The next thing we'll do is we'll expand those brackets. So it would be 6. 3 will times by the 2, 6 sine squared x cos x equals 2 cos cubed x. We'll take everything onto the same side, so it'll be 6 sine squared x cos x equals 2 cos, so minus 2 cos cubed x equals 0. Let's now factorize out, let's divide by 2 and factorize out cos. Now you are allowed to divide by 2 because 2 isn't 0, but cos x could be 0. That's why you have to factorize it out. So it's going to be 3 sine squared x minus cos squared x equals 0. The next thing I'll probably do with what's inside the bracket is use the 1 minus sine squared identity for cos squared. So that's going to make it minus 1 minus sine squared x for the cos squared. And then that's going to turn into cos x bracket. It's going to be 4 sine squared x minus 1 equals 0. So I've got 3 little equations here. It's going to be cos x equals 0, or sine x equals a half, or sine x equals minus a half. So from 0 to 360, that's going to be 0, sorry, no, not 0, pi by 2, 3 pi by 2, So when I've done from 0 to 360 like that, it's going to be 90 and 270. For this one here, it's going to be 30 and 150. And for this one here, it's going to be 210 and 330. Okay, so there we are. Those are the solutions for this pretty tricky little double angle formula trig equation. Right, then let's move on to the next question. We've got sine 3x minus sine x equals 0. So sine 3x is a new one. So what we could do with this one is to work out its identity. This is not one that I would remember in a standard way, but I know that it would be sine x plus 2x. And then I can just use the angle addition formula for sine, so it would be sine x, and then it would be cos 2x plus sine 2x cos x. The next thing I do is turn all of the cos 2x and sine 2x identities into a single angle, preferably the sine version if they have a certain version. This one would be 1 minus 2 sine squared x. And then this one here would be 2 sine x cos x, but we already have a cos x at the back, so that would now be cos x squared. The next thing we'd do is expand the bracket, so it would be sine x minus 2 sine cubed x, and then it would be plus 2, and this would be 1 minus sine squared, so it would be sine x minus 2 sine cubed x. So I've turned this cos squared into 1 minus sine squared and got that out of the expansion. To simplify it, it would then be 3 sine x minus 4 sine cubed x. Okay, so I'll now use this in the above question. So it's going to be 3 sine x minus 4 sine cubed x minus sine x equals 0. So what does that mean? We're going to get 2 sine x when we simplify. 2 sine x minus 4 sine cubed x equals 0. We could then factorise out, we could divide by 2 and then factorise out the sine. So it'd be 1 minus 2 sine squared x. And then we get two little equations. We either get sine x equals 0, in which case x is equal to 0, 180 and 360. Or we get this expression here is equal to 0, in which case sine x will equal positive 1 over root 2, or sine x will equal minus 1 over root 2. In which case we then need to solve these equations, so it's going to be 45 degrees and 135 degrees. And then for this one here, it's going to be 180, 225 and 315. Yeah, so yes, that's exactly right. So there we are. These are our 1, 2, 3, 4, 5, 6, 7 solutions to this equation here. Okay, so let's move on to the next question. And in this question we have 8 cos of an angle times sine of an angle. So what we could do here is we could expand the brackets using the double angle, the angle addition formulas. But what I've also noticed is I've recalled that sine 2 theta is equal to 2 sine theta cos theta. Okay, so what I could do now is I could put the theta in for pi x plus pi by 6 and end up turning this identity, this equation on the top here, into 4 sine 2 theta, and 2 times this angle here will be 2x plus pi by 3 equals 1. Now the next thing I need to do is change my angle so it has this angle in the middle. So I'll double both the sides of the inequality first, 0 to 4 pi, and then I'll add pi by 3 onto both sides, so it'd be pi by 3 to 2x plus pi by 3 to At 4 pi will be 12 pi by 3, so add another pi, 13 pi by 3. And it'd be actually helpful to know what decimal this will be going up to. 13 pi by 3 is equivalent to 13.6. And pi by 3 is approximately 1, because pi is 3.14, so it's about 1. So anything above 1 I'll check. Okay, so the next thing I think I'll do is I'll substitute in y for 2x plus pi by 3. So I'm going to write next sine y is equal to 1/4. So grab the calculator, make sure it's in radians mode, and sine inverse 0.25 or 1/4, which will make it 0.253. 0.253 is outside of the range from about 1 to 13.6, so that's not going to be a final answer. So I'll work out what some final answers are. The next answer for y will be pi minus 0.253, which will equal, so I'll store this current value on my calculator for a, store for a, and then I'll do pi minus a, and that will give me 2.89. Now at some point I know I'm going to have to solve this and work out what x is, so I'll now do that while 2.89 is fresh in my calculator. I'm going to take away pi by 3 and divide by 2. Take away pi by 3. Hold on, take away brackets pi by 3 and then divide by 2. So that's 0.92. So my first x solution is 0.92. The next value I'll work out for y will be 2 pi plus 0.253. Remember, 0.253 is stored on the calculator as a at the moment, so I'll write in 2 pi plus a, using the a on the calculator. That would be 6.54. And then to find x, I'll need to take away pi by 3 and divide by 2. So take away fraction pi by 3 and then divide by 2, and that will give me 2.74. The next solution for y will be 3 pi minus 0.253. So 3 pi minus the value a on my calculator, 9.117, and then to work out x I'll need to subtract pi by 3 and divide by 2. So that would be 4.06. All these solutions are still valid. Next one will be 4 pi plus 0.253, which will equal, so that would be 4 pi plus the value a on my calculator, 12.8. That's still in the range, it goes up to 13.6. So the next thing I'll need to do is then subtract pi by 3 and then divide by 2. So that would be 5.89. And if I go any further, I'll run out of solutions and I'll go over the 13.6 limit for y. So there we are. These are the answers for this equation here. So we've used a double angle formula to simplify this bit here into sine 2 theta. Alright, let's move on to the next one. And I think in this question, when it's a fraction like this, I actually prefer to double the other angle. So what I'm going to do now is I'm going to set x over 2 equal to my angle y. So therefore x on its own will equal 2y. So the first thing I'm going to do with this question is replace the x over 2 with y. And then the sine x will become sine 2y, and that will equal 0. And if I'm changing the angle, then I'll need to change this domain here, so I'll need to divide it by 2, so that'll be 0 to y to pi. I've divided it by 2 here. Okay, so now I'll use the double angle formula on the sine 2y. That would be 2 sine y cos y plus sine y equals 0. Factorise out the sine y. 2 cos y plus 1. So I get some solutions here. I get y equals, so sine y equals 0, in which case 0 and pi are solutions. So therefore x will be 0 and 2 pi. And then the next one here would be cos y equals minus a half. And the only solution in between 0 to pi for this will be cos inverse minus 0.5 will be 2 pi by 3. The other solution would be 4 pi by 3, which will be outside of this range for y. And for x, we then double it to work out what x is. We're going to get 4 pi by 3. So these are our three solutions that solve this equation: 0, 2 pi, and 4 pi by 3. Okay, let's move on to the next question, and we've got this little tricky one here. We've got cos 3x and a cos 2x. Let's sort out the cos 3x first. I'm sure there's an identity to do with cos 3x. So that's going to be cos 2x plus x, in which case that's going to be cos 2x cos x minus, because it is a minus in the angle addition formulae, sine 2x sine x. So let's expand both of these. I think what I'll do is I'll expand this one into 2 sine squared x cos x, and I can always turn the sine squared into a cos squared, so I'll use the cos squared one for this one, 2 cos squared x minus 1 times by cos x. And expand the brackets, we get 3 cos cubed x. So why 3? I don't know why I'd put 3 there. It's just a 2 still. 2 cos cubed x minus cos x. And then I can always turn the sine squared into 1 minus cos squared. So that's going to be plus 2 cos cubed x minus 2 cos x. And then we simplify that to 4 cos cubed x minus, so 4, and then minus 3 cos x. The next thing we'll also do is remind ourselves of the cos double angle formula, which is this expression here. Alright, so now that we've got that, we can now write out our equation. It's going to be 4 cos cubed x minus 3. Hold on, if I've got a plus here, I could just simplify that straight away into minus 2 cos x equals 2 cos squared x minus 1. Okay, the next thing will be to move everything onto the same side. So it's going to be 4 cos cubed x minus 2 cos squared x minus 2 cos x plus 1 equals 0. Okay, the next thing to do will be to then go into your cubic polynomial solver and solve this cubic polynomial. And the calculator gives us 1 over root 2 minus 1 over root 2 and a half. Now, probably the reason for that is we could probably factorize it into 2 cos x minus 1 and then cos squared x minus 1 as well. And you can see that if you expand that, you'll get the line above. So these are our 3 little baby equations that now need solving. So let's go ahead and do that. The first solution will be pi by 4 and 7 pi by 4. For the second equation, it's going to be x equals 3 pi by 4 and 5 pi by 4. And for the last equation, half is going to be pi by 3 and 5 pi by 3. So So there we are, these are the 6 solutions for this equation here. Okay, moving on to the next question, and we'll use that little strategy we saw before, which was to turn x over 2 into y, so that we turn x into 2y. So it just doubles both of the angles. So we're going to write 3 sine x, not x, y rather, plus cos 2y equals 2. So we also have to change the interval, so it's going to be from 0 down to y down to pi. We're going to half both of these sides. Let's now solve this. We've got cos 2y, so there's a cos double angle formula that will be helpful here. It's going to be 1 minus 2 sine squared y equals 2. Let's move everything onto the right hand side now. It'll be 2 sine squared y minus 3 sine y, and then minus 1 on that side. So let's now factorize it. It'll be 2 sine y and sine y, and then it's going to be minus no, it'd be plus 1 on this side, won't it? Because if we take away the 1 onto that side, it'd be plus 1, and it'd be minus 1 and minus 1. So sine y will equal a half, and sine y will equal 1. And luckily that will happen for this one here. We'll have pi by 2 as our answer for that one, and this one here will be y equals pi by 6 and 5 pi by 6 as well. So the solutions for x are going to be pi by 3, 5 pi by 3, and for this one here we double it, and we're going to get pi for this solution here. Lovely, so there we are, that's the answer for this question here. Let's move on to the next one, and again we're going to use that sneaky strategy of setting x over 2 equal to y, so therefore x will equal 2y. So the first thing we'll do is we'll sort out our interval. It's now going to be from 0 to y to 180. I'll change my calculator into radians mode, and then I'll half the angles, so it'll be 2 cos y, no 2y actually, plus 1 equals sine y. So similar to before, we want a double angle formula for cos in terms of sine. So it's going to be 2 brackets, 2 sine, no, 2, it's going to be 1 minus 2 sine squared y plus the 1 equals sine y. Expand the brackets and we get 2 minus 4 sine squared y plus 1 equals sine y. Let's move everything onto the right hand side, and we're going to get 4 sine squared y. 2 plus 1 is 3, so it would be minus 3. So it's plus sine y, and then minus 3. Let's see if we can factorize it now. I think 4 is going to be in one of the brackets, just a sine in the other. And if we do plus 1 over this side and minus 3 over this side, minus 3 sine y plus 4 sine y to give us the sine y in the middle there. Lovely. So we've got sine y equals 3/4 and sine y equals minus 1. And that will happen at, outside of this interval actually happen at 270, so that's not going to be a solution in our that we'll actually consider. We'll find the first set of solutions though. Make sure calculator's in degrees mode, and then sine inverse 3 divided by 4. So that will give us 48.6, and then we'll have to then do 180 minus this answer, 131. And then we'll work out what x is by doubling everything. So 48.6 doubled, let's just grab the proper answer value and times it by 2. That'll be 97.2. And then when we go for the other one, that'll be 180 minus that previous answer, but then double it, we get 263 to the correct number of significant figures. So there we are. That's the answer for this question then. So let's move on to the next one. Okay then, so moving on to the next one, we've got the sine double angle formula appear here. So we have to substitute that in for 2 sine x cos x. And then plus 2 sine squared x equals 1. Okay, let's expand the brackets. So it's going to be 2 root 3 sine x cos x, and then plus 2 sine squared x, and maybe we'll take away the 1 onto the other side. Okay, right. Oh, actually, hold on. This might be a different type of question. Actually, let's move this component here onto the other side and turn this back into sine 2x. Hold on, I've just seen how to do this question. 1 minus 2 sine squared x. Now what you can see here, I didn't really feel like there was much happening here, so I'd move this onto the other side because this is exactly equal to cos 2x. That's why it's really helpful to have them just instantly recallable in your mind. Because what we're now going to do is we're now going to divide the cos 2x on the other side to turn it into a tan. So it's going to be root 3 tan 2x. And so what I'm doing from here to here is dividing by cos 2x on both sides, so I'll be left with 1 on the right hand side. And in this special case, you're allowed to divide by 2, you're allowed to divide by cos because you are creating a tan, and tan takes into account that sometimes cos will equal 0. The next thing I'll need to do is I'll need to divide by root 3 on both sides, and then double this angle, so it's going to be from 0 to 2x to 720. Now let's work out what the 2x answer will be. So calculator in degrees mode, tan inverse 1 over root 3, and we get 30 degrees. And then for tan solutions, you just add 180 each time. So add 180, then add another 180 to 390. Still inside the range, we need to go all the way up to 720. Add 180 again, 570. Add 180 again, 750. That's outside the range, so stop there. Next thing we'll do is we'll half all of the angles. So 15 degrees, 105 degrees. With this one here, it's going to be 295 degrees, and with this one here, 570 divided by 2, 285 degrees. Okay, so that's probably wrong, isn't it? 195 degrees. That's better, that's better, that's better. Alright, there we are. That's the answer to that question then. Let's move on to the next one, and it's 2 cos x plus cosec equals 0. So let's first of all put everything on the same on them in terms of cos and sine. Let's move the fraction onto the other side. And then times everything by sine, and we get 2 sine x cos x equals minus 1. And we identify that the thing on the left hand side will equal sine 2x. I think we've done a similar question to this before. So we will then double everything on the angle, and then we'll start solving it. So 2x on the sine graph will equal 3 pi by 2 and 7 pi by 2. And then we'll divide everything by 2, so that will give us 3 pi by 4 and 7 pi by 4. And there we are, those are the two answers for this equation. Let's move on to the next one, and this is going to be a very similar one, I reckon. So it's going to be write it as sines and coses first, 1 over 4 cos x. Move it on to the other side and times by 4 cos x. I'll do that all in one go. And then use the angle identity, so it would be 2 sine 2x equals minus 1, so sine 2x equals minus half. Double the angles on both sides, so it would be from 2x to 2 pi. So then 2x is equal to, that's pi by 6, so it would be 7 pi by 6 and 11 pi by 6. And that's all the answers up to 2 pi. So then half all of these, it would be 7 pi by 12 and 11 pi by 12. And there we are, those are the answers for that question. Let's move on to the next one, and a little tricky one here. Let's write it in terms of sine and cos first. It's going to be 4 sine x cos x equals cos over sine. Let's times the sine onto the other side. So it'd be 4 sine squared x cos x. And then let's take the cos onto the other side. So subtract cos. That will leave us with 0. So let's now factorise out the cos. 4 sine squared x minus 1 will equal 0. So now we've got 3 little equations. Either cos x will equal 0, so that's going to be 90 and 270, or sine x will equal a half, or sine x will equal minus a half. So therefore x will be 30 or 150, or x will be 210 or 330. And there we are, those are the 6 answers for this question here. Okay, let's move on to the next question, and it's going to be difficult to know which way this one's going to go. It's going to be difficult to know which version of cos 2x we are actually going to want. So actually what I'm going to do is I'm going to use the one that we don't use very often, which is 2 cos squared minus sine squared, one with both of the squared functions in it. The next thing I'll do is expand the bracket, so it's going to be 2 minus 2 cos squared x plus 2 sine squared equals tan x. Now I'd quite like this 2 to disappear, so if I group it with the 2 cos squared, then 2 minus 2 cos squared turns it into 2 sine squared, so this whole thing will then turn into 4 sine squared x equals tan x. Now tan x is sine over cos. So if I now multiply both sides by cos, I'm going to get 4 sine squared x cos x equals sine x. Let's move it onto the other side and factorise it. So it's going to be sine x bracket 4 sine x cos x, and then minus 1 equals 0. You can see where this is now going. It's going to be sine x at the front still, and then it's going to be 2 sine 2x in the bracket minus 1 equals 0. So our baby equations are sine x equals 0, in which case we won't use 0 because that's not one of the solutions, or pi. And then we're going to have to double this angle for the little equation in the brackets. So it's going to be 0 to 2x all the way up to 2 pi. So it's going to be sine 2x equals a half. So 2x will equal pi by 6 and 5 pi by 6. And those are these solutions there. But x will therefore equal pi by 12 and 5 pi by 12. So there we are, we have 1, 2, 3, 4 solutions to this equation here. Okay, let's move on to the next equation, and I think first of all we'll have to sort out this fraction on the left hand side. So it's going to be sine squared x plus cos squared x over sine x cos x, and then equals 4. So you can see what's going to happen here. The sine squared plus cos squared on the top will turn into 1, and then it will be 4 sine x cos x on the bottom, so on the right hand side. Then we'll turn it into 2 sine 2x, and then half both sides, and then the 2x will be from 0 to 2x to 720, so 2x will equal 30, 150, 390, and 690. Hold on, no, not 690. It's going to be 150 add 100, 150 add 360, which would be 510. So then x is going to equal 15, 75. 390 divided by 2 is 195. And 510 divided by 2 is 255. So there we are. These are the 4 answers for this equation here. Okay, let's move on to the next one. Wowzers. Okay, so the first thing I'll do is I'll write it out in terms of sines and coses. So it'd be 2 cos x equals 2 sine squared x over cos x plus 1 over cos x. Okay, well that will be easy to simplify the fraction on the right hand side. So what we're going to do, we might just times everything by cos. So it'd be 2 cos squared x equals 2 sine squared x plus 1. Right, okay, what I think I'm going to do here, maybe there's a couple of different ways of doing it, is I'm going to move the 2 sine squared and cos squareds onto the left, factorise the 2 out, and then it will be cos squared minus sine squared that will equal 1. And we know that sine squared, cos squared minus sine squared is the cos double angle formula. Equals 1. So then divide it by 2. Then sort out your angle. It's going to be from 0 to 2x to 4 pi. So then my 2x answers are going to be 60 degrees, or pi by 3. Then it will be 5 pi by 3, 7 pi by 3, and 11 pi by 3. Divide everything by 2 and you'll have pi by 6, 5 pi by 6, 7 pi by 6, and 11 pi by 6. And there we are, that's the answer to this question. Right, okay, this question here looks like a tough one. I think what we'll do first then is, well, there's definitely going to be something to do with sine 2x, the double angle formula there. There's only one of those, so it might as well turn it into it first. So it's going to be 2 sine x cos x. And then that's all going to be squared. And on the left-hand side, let's think about what this is going to be. Well, we'll do sine over cos first. And then inside the brackets, it's going to be helpful to choose the cos double angle formula that will cancel this 1 out. So it's 2 cos squared x minus 1. So it will cancel out the 1 there. So we'll simplify that to 2 cos squared x. Okay, let's now sort out the left-hand side. This cos will cancel out one of those coses, so it would be 2 sine x cos x. Now actually, that there is the sine double angle formula. So actually what I might do is I might turn this back into the sine double angle formula. And now we've got sine 2x on this side and 2 sine squared x on this side. So it now makes sense that to turn this question into a question where we're just going to solve it as a double angle, minus sine 2x. So I'll double my angle, it would be from 0 to 2x to 180. And I'll start factorising out sine 2x. Inside the brackets would be 2 sine x minus 1. So either sine 2x will equal 0, in which case 2x will be 0 or 180, or sine 2x will equal 1/2, in which case 2x is equal to, it's going to be 30 degrees or 150 degrees, in which case we then need to divide everything by 2, so it'd be 0, 90 degrees, 15 degrees, or 75 degrees. So there we are, we have 4 solutions to that equation there. And let's move on to the final one, very tricky one here. Okay, and then moving on to the final question on the video. I'm going to do this quite small because I've seen how I'm going to do the answer and it's quite a long one. So the first part is to just write this as 4 sine 2x over cos 2x. And the next part will be to write it in terms of sines and coses. So it's going to be 3 cos x over sine x. And then this would be multiplied by sec squared, which is 1 over cos squared x. Now simplifying this, it's going to cancel out the cos on the top and the bottom of this one. So I'm going to get 4 sine 2x over cos 2x, and then plus 3 over sine x cos x. And looking at the denominator of the right-hand fraction and thinking, is this nearly a double angle formula? Well, it is if I put a 2 in front of it. I can't just create 2's out of nowhere. I'll have to balance it out with putting a 6 on the top. So now what I've got is I've got 4 sine 2x over cos 2x plus 6 over sine 2x. Because the double angle formula for this denominator is sine 2x. Okay, the next thing I'm going to do then is add these fractions together, and then if it equals 0, then it's just the numerator that's going to equal 0. So it's going to be 4 sine squared 2x plus 6 cos 2x, and then that will all be over cos 2x sine 2x, but then whenever you've got a fraction that equals 0, it doesn't matter what the denominator is, it's the numerator that equals 0. So this thing will then equal 0, the numerator of this combined fraction. I've got sine squared with a cos, so I could turn that into 1 minus cos squared. And I think I'm now just going to solve this as a double angle question where I expand this from 0 to 2 pi to 0 to 4 pi. So when I expand the brackets and make the cos squared positive, I'm eventually going to get, and I'll divide by 2 as well, I'm going to get to 2 cos squared 2x, and then it would be minus 3 cos 2x, and then move the 4 on the other side, so minus 2 equals 0. I've divided everything by 2 as well. Then we can use some factorization, so it would be 2 cos 2x, and then cos 2x equals 0, so that would be minus 2 on this side and plus 1 on that side. So then cos 2x equals minus half, and then nothing will happen on this side because you can't get a cos equaling 2. The next thing will be 2x will equal cos inverse in radians mode, please. Cos inverse, minus 0.5, that will give us 2 pi by 3. The next one will be 4 pi by 3. And then the next solutions on from there will be just add 2 pi onto the answers. So add 2 pi. That would be 8 pi by 3 and 10 pi by 3. Okay, so now the final bit will be to divide everything by 2. So it would be pi by 3, 2 pi by 3, 4 pi by 3, and 5 pi by 3. And there we are. That's a really complicated question there, because usually what you want to do with the double angle formula is expand it into single angles, but actually sometimes it's better just to keep things in double angles and then solve it as a double angle. Expand your domain to a double angle and then just half all of your angles at the end. So there we are. Hopefully you found this video helpful. Feel free to come back to it in the future just to practice your solving trigonometric equations ability. Yeah, hopefully you found this video helpful.